Hello everyone, I'm Norihiro Yoshida from Nagoya University in Japan. On behalf of my student Natsuki Tsuzuki, I'll talk about quantitative comparison of coverage-based Greybox Fuzzers. This is collaboration work with Fukuoka Institute of Technology and National Institute of Technology, Toyota College. As you may know, there are many coverage-based Greybox fuzzers. Firstly, AFL is developed by Zelensky in 2013. After that, many researchers have developed fuzzers by extending AFL. For example, AFL Fast, AFL Go, and FairFuzz. Before using fuzzers, developers want to know two questions as you can see on the slide. First question is, the newest fuzzer is always better than the others? If yes, developers want to use only the newest one. The second question is how each fuzzer works better than use of default test suite. To start using fuzzers, developers want to know fuzzer is better than just running test cases. Unfortunately, the existing fuzzers are evaluated by different criteria because there is no common benchmark dataset for fuzzing tool. The table on the slide shows fuzzing targets and evaluation criteria for each fuzzer. The evaluation of FL Fast uses bin utils 2.26. However, the evaluation of FairFuzz uses different version of bin utils 2.28. Also, the evaluation of FL Fast uses unique crash, ground truth, and line coverage as evaluation criteria. However, the evaluation of FL Go uses basic block coverage and ground truth as evaluation criteria. Therefore, it is difficult to compare experimental results according to these papers. Here is our research overview. In this study, we prepared a unified collection of fuzzing targets and then compared the existing fuzzers. We used two evaluation measures. One is the number of executed passes. Another one is branch coverage. We will answer three research questions. First one is a neural AFL-based fuzzers able to execute significantly a larger number of passes? Research question 2 is, does an AFL-based fuzzers improve branch coverage? The last one is, does a neural AFL-based fuzzers always achieve higher coverage? In this study, as the existing fuzzers, we use 5 versions of AFL, and also we use AFL Fast, AFL Go, and FairFuzz. As fuzzing targets, we use 3 versions of bin utils. Each execution of a fuzzer is terminated after 6 hours. The table on the slide shows the result of significant test in terms of passes. We used still-to-us test for judging the significance. As you can see on the slide, we confirmed significant difference between Fairfax and the other Fuzzers in most cases. Therefore, the answer to research question 1 is, in most cases, the newest fuzzer Fairfax executes significantly larger number of passes. The bar graph in this slide illustrates branch coverage in the non-use and use of fuzzers. Black bar represents branch coverage in the case of running default test cases for each command. On the other hand, the other bars represents branch coverage in the case of running fuzzers. As you can see on the slide, black bar is significantly lower than the others. So the answer to research question 2 is the fuzzers can improve branch coverage compared to the case of running default test suite. The table on the slides shows the result of significant test in terms of branch coverage. We use still-to-us test for judging the significance as well as research question 1. As you can see on the table, we cannot confirm any significant difference between the existing fuzzers. So the answer to research question 3 is the newer fuzzer does not always achieve higher branch coverage. As discussion, we will discuss 3 findings from this study. The most surprising finding of this paper is the results are totally different between the number of passes and branch coverage. This means different evaluation criteria are possible to lead to different conclusions in the case of evaluation of fuzzers. Therefore, researchers in this topic should carefully choose evaluation criteria for their research purpose. The second finding is newer fuzzers are unoptimized for quality assurance process based on branch coverage. This implies there are research opportunities for developing new fuzzers for improving branch coverage. The last finding is the use of fuzzers can improve branch coverage compared to running default test cases. Thank you for listening.